IOTA is short for Internet Outage Detection and Analysis. It's a system with a public dashboard that monitors the internet around the world 24 by 7 to measure internet outages, that is, events where users experience complete disconnection from the internet. IOTA is actively under development at CADA, a research lab in the University of California, San Diego. CADA, which stands for the Center for Applied Internet Data Analysis, builds infrastructure to perform large-scale internet measurements and makes curated data available to other researchers, political scientists, policymakers, and the general public. The idea behind IOTA was conceived in 2011 when researchers at CADA had studied large shutdown events in Egypt and Libya during the Arab Spring. Back in the day, it took us several months to obtain all the data and crunch through it and complete the investigation. In the time since, we've been able to build a system that is capable of monitoring the internet 24 by 7 and detects internet outages due to shutdowns and other causes such as power outages. It does this monitoring for countries, regions, and networks from around the world and in near real time. What's more, its data is available publicly and anybody can access it. Before diving in depth into IOTA, however, let's clarify what kinds of outages IOTA detects and what scenarios it's appropriate for. IOTA is focused upon scenarios involving complete internet connectivity outages, such as the event that occurred in Iran in November 2019, where a significant portion of the users in the country had no internet connectivity at all. Other events, such as power outages, can also result in large internet connectivity outages, since users will not be able to access the internet. An example of such an event that was visible in IOTA was a massive power outage in Venezuela in March of 2019. It's also worth discussing a scenario that IOTA is not appropriate for: detecting website or social media blocking. During these blocking events, users are unable to access specific websites such as Twitter or Wikipedia or Google, but are able to access other websites. There are great tools like ONI, Censored Planet, IC Lab that look at website social media blocking. IOTA is instead focused upon complete internet connectivity outages. To access the dashboard, first go to iota.cada.org. Then click on the link that says Overview Dashboard. By default, the dashboard shows internet outages during the last 24 hours. We can choose a different time range if we wish, as we will see shortly. Now, you will notice a world map. The map shows potential outages by highlighting the affected countries in shades ranging from blue to red. The more red the shade, the more severe the outage. In the table to the right, you can see the alert feed, a list of these outages ordered by severity. The second column to the left shows the overall outage score, a single unbounded number that captures the severity of an outage. Again, the more red a table cell, the more severe it is compared to other cells. To the right of this column, you can find the severity broken down for IOTA's three data sources: active probing, BGP, and the darknet. The active probing data source represents ping response data from networks all around the world. From machines under our control, we continuously ping millions of networks on the internet. Intuitively, networks that are responding to our pings have working internet connectivity. If several networks in a country suddenly stop responding to our pings, we may have found an outage. The BGP data source represents routing information, global routing information that each router exchanges with other routers. As you know, internet packets from one part of the internet reach other parts by going through several routers along the way. These routers continuously communicate with each other on what the best routes are to various destinations using an internet protocol called BGP. By monitoring BGP communication, IOTA assesses when there is a significant reduction in the number of destinations that can be reached within a country. The last and most esoteric of our data sources is the darknet. And the first thing I'll note is that the darknet has nothing to do with the dark web. In fact, internally we call this Internet Background Radiation, or IBR for short. This traffic represents liveness traffic that is often from actual user machines. This background noise traffic is sourced by millions of machines worldwide and is often a result of these machines being infected by malware. Thanks to infrastructure at CAIDA, we are able to see a portion of this traffic. And this traffic is able to give us a liveness signal collected from user machines. Again, IOTA's intuition is that when there is a significant drop in the time series for this liveness signal from IBR, it could be due to a potential outage. Now, these three signals are complementary. Depending upon the nature of the outage, it may be visible in all three or only a few. In addition to the country-level outages that you see here, IOTA also finds outages affecting specific regions in the world. Sometimes an outage may not affect an entire country, but may affect a specific region in the country, like the shutdown event that affected the Indian state of Jammu and Kashmir in August of 2019. Such regional outages will be displayed here. Further, IOTA also detects outages at the network level, that is, at the AS or autonomous system granularity. Now, let's walk over how we would use IOTA to explore recent internet connectivity outages. The dashboard shows you potential outages that happened in the last 24 hours by default. We see here that each of the entries in the table on the right is a link that we can click on to see additional information about the outage affecting the country. So let's click on the first country here, which is Côte d'Ivoire or Ivory Coast. When we click on a country, we will be taken to a page that displays the time series signals for IOTA's data sources along with auto-generated alerts which indicate that a potential outage has occurred on the right of the page. You can see the signals from the three IOTA data sources here. By default, IOTA normalizes these signals so that they lie between 0 and 1, enabling easy visual comparison across these signals. You can turn off the normalization by clicking on the Normalize button here to see the raw values of these signals. Similarly, it is also possible to turn off alert bands, which refer to these bands here by clicking on the Alert Bands button. Another useful visualization feature is that you can focus upon one of these signals by double-clicking on it. Single-clicking the other signals will toggle them on or off. You can also hover over the signals to see the timestamp, which is on the x-axis, and the y-axis value at each point. For example, you can see here that the active probing signal dropped from 0.96 at August 13, 12:20 a.m. to 0.48 at August 13, 12:50 a.m. Now, as we mentioned before, these three signals are complementary, and this outage detected by IOTA shows this complementarity. During this outage, we see that the BGP signal had a relatively small drop that lasted from 1:05 a.m. to 1:25 a.m. The active probing signal had a larger drop that also lasted longer. On the other hand, the outage is not clearly visible in the darknet signal. Depending upon the nature of the outage, it may be visible in all three IOTA signals, or it may be visible only in a subset of these signals. Okay, so now that we've seen how to examine outages that occurred in the last 24 hours, let's now examine outages in the last week. We can change the window of time that we are interested in by selecting the time range here. Note that IOTA allows us to search for a time range of up to a month. However, this month can be any month since July 2016. We can either choose the last week by selecting the dates here, or by choosing the -7 days option here. IOTA will now display outages detected over the last week, ordered by severity. Let's click on Belarus here, which has been undergoing some political turmoil since the presidential election on August 9th. We can see that IOTA has detected several outages during this time. Once again, we see that these outages are visible in two of IOTA signals but not in the third, again emphasizing the complementary nature of these signals. Note that there is also a dip in the active probing signal on August 7th. Now, since we only observed the drop in one of IOTA signals, this may or may not have been an outage. There are other reasons why there could sometimes be a drop in an individual IOTA signal. However, when there is a drop in two different IOTA signals at the same time, that is a much stronger indication of an outage. Thus, a good rule of thumb is to look for outages that are visible in at least two of IOTA signals. Let us now look into a common use case for IOTA. We often hear anecdotal reports about a complete internet connectivity shutdown event for a country, and we'd like to check if the IOTA signals for that country contain any evidence of a connectivity outage that could have resulted due to the shutdown. As an example use case, let's consider Syria. There have been reports over the years that the Syrian government shuts down the internet countrywide during times of school exams to prevent cheating. In 2019, we observed several likely exam-related outages for Syria in IOTA in the last couple of weeks of June. So let's investigate if there have been outages for Syria in 2020 also towards the end of June. So let's first visit IOTA's dashboard. Now, since we are interested in Syria, let's search for Syria in the search bar over here. The search bar allows us to search for a country, region, or AS. By default, it's set to country. In this particular case, since we are looking for country-level outages, we don't need to change the default setting. Now, as we type our first S into the search bar, we see different matches, each of which is a clickable link, but we don't yet see Syria. Let's type Y, and we now see the clickable link for Syria. Let's click on it so that we can see the IOTA signals for Syria. Now, by default, IOTA displays signals from its data sources over the last 24 hours. However, we are interested in IOTA signals for Syria from June 2020. So let's select dates in the last week of June 2020, say from June 23, 2020 to June 30th, 2020. We can see on the right that IOTA has automatically generated a few alerts indicating potential outages during this time interval. And indeed, the time series signals for IOTA's data sources show several drops during this time. Let's further investigate these drops by zooming into one of them. In order to zoom, let's click and drag the area that we wish to zoom into. When we zoom in, we can see that the outage began in all three IOTA data sources at around 1 a.m. UTC. Let's click on the Reset Zoom button here to get out of the zoom. Let's zoom into the next outage to see when it began. We see that the next outage also began at 1 a.m. UTC. Note that the outages caused by the exam-related internet connectivity shutdowns in Syria in earlier years also had similar timing patterns. They also began in all three IOTA signals at 1 a.m. UTC. When we take the timing patterns for these outages together with the additional context of the timing patterns of the previous exam-related shutdowns, we can then reason that these outages observed in Syria are indeed consistent with exam-related shutdowns. Let us now take a look at how to investigate outages affecting specific regions in a country using IOTA. Sometimes, outages may affect a particular region within a country much more than it affects other regions. For example, if a government orders a full internet connectivity shutdown for a specific region in a country, then that region may observe a significant internet outage, whereas the country, when considered as a whole, may not observe a particularly large outage. As an example use case for investigating regional outages, let's consider a widely reported upon shutdown event in Jammu and Kashmir, a state in India. This event was supposed to have occurred in early August 2019. So let's look at the IOTA signals in Jammu and Kashmir during this time. Let's begin by visiting IOTA's dashboard. Let's use the search bar here to search for Jammu and Kashmir. The search bar allows us to search for a country, region, or AS, but by default it's set to country. Since we are looking for a specific region, let's change this setting to region. As we start typing into the search bar, we see that the link for Jammu and Kashmir appears. Let's click on the link so that we can see the IOTA signals for Jammu and Kashmir. By default, IOTA displays signals from its data sources over the last 24 hours. However, we are interested in IOTA signals for Jammu and Kashmir from early August 2019. So let's specify the date range that we are interested in. So let's select dates, say, let's go to 2019, from the 28th of July in 2019 to, say, the 11th of August. IOTA will now display 2 weeks of time series signals for the Indian region of Jammu and Kashmir. We are looking to see whether these signals are consistent with a potential shutdown event. Let's focus first upon the active probing data source. You will notice that there are a few minor fluctuations before August 4th, but there is a drop in the signal on August 4th which correlates with the time when the shutdown event was supposed to have begun, according to news reports and reports from volunteers on the ground. Next, let's examine the darknet data source. The darknet signal tends to contain diurnal patterns, reflecting end-user machines in Jammu and Kashmir being online and active during the day and then becoming inactive during the night. Now, on August 4th, the darknet data source does not show as pronounced a drop as the active probing data source. However, we do observe that the magnitude of the signal before the shutdown was larger than the magnitude of the signal after the shutdown. This difference is visible quite clearly when we compare the highest point of the signal before and after the 4th of August. If we had been examining the darknet signal in isolation, The variation in the signal here is tricky to interpret. However, given the context and also the small but clear drop in the active probing data source during this time, we can infer that the IOTA signals are consistent with an internet shutdown event in Jammu and Kashmir. Now, you may be wondering why these signals did not drop all the way to zero. It's possible that the shutdown did not affect every internet connected machine in Jammu and Kashmir. Perhaps parts of the region continued to have connectivity, or perhaps machines belonging to the government continued to have connectivity. You'll also notice that there is a gap in the BGP signal. Gaps like these are not indicative of internet outages. They indicate issues or problems on IOTA's infrastructure which resulted in loss of data. While we work continuously to avoid such issues, they nevertheless do occur, and they should not be misinterpreted as evidence of internet outages. Let us now take a look at how to investigate outages affecting specific networks using IOTA. As a use case, let's consider a potential cable cut from 2019. There were reports that a submarine cable cut had resulted in internet outages for Globe Telecom, an AS in the Philippines, on the 4th of June 2019. Let's begin by visiting IOTA's dashboard. Let's use the search bar here to search for Globe Telecom. The search bar allows us to search for a country, region, or AS, but by default, it's set to country. Since we are looking for a specific autonomous system, let's change this setting to ASN. As we start typing into the search bar, we see that the link for Globe Telecom appears. Let's click on the link so that we can see the IOTA signals for this AS. By default, IOTA displays signals from its data sources over the last 24 hours. However, we are interested in IOTA signals for this AS on the 4th of June in 2019. So let's specify the date range that we are interested in. IOTA will now display the signals for this AS on the 4th of June. We see on the right that IOTA has automatically generated a few alerts indicating potential outages during this time. Examining the signals, we observe that they do indeed appear to have been near simultaneous drops in the BGP and active probing signals. Although the darknet data source does not have a significant drop, the fact that the other two IOTA signals show a simultaneous drop suggests that this was not an anomaly with IOTA's data sources. Instead, those drops may indeed be related to the reported cable cut. IOTA provides the ability to view outages at the country, region, and AS level. Some large outage events can be visible at the country level granularity. That is, they may have significantly affected a country when considered as a whole, and may also be visible at the region level granularity for some regions and AS level granularity for some networks within that country. As a case study of such an outage, let's consider the large shutdown event that affected Iran in November of 2019. We will analyze the country level, region level, and AS level IOTA signals to perform a deep dive into this event and uncover differences in how the outage affected different networks. Let's begin by visiting IOTA's dashboard. Let's search for Iran in the search bar and click on the link. This will display the country-wide IOTA signals for Iran in the last 24 hours. Now, this shutdown started on November 16th, 2019 and lasted several days. So let's set the date range to cover this event. Let's go to 2019, select November, and set the start date to be, say, November 10th. And until, let's select 2019 here again. Let's go to November and set the until date to be, say, November 25th and hit apply. Since this query will fetch data from a 2-week period, it will take a few seconds to load. We see that the internet was relatively stable until the 16th of November. On 16th November, however, we observed drops in all three of IOTA's data sources. From around the 24th of November, we see the signals rise again, suggesting recovery from the outage. Let's next look at region-level outages to see which regions in Iran were affected by this outage. We can see which regions were affected by clicking here on Regional Outages for Iran. We see here that this particular outage seems to have affected a majority of the regions in Iran. Let's next examine AS-level outages to see how individual networks in Iran had been affected and to see if there are differences. Did some networks continue to remain internet connected during the shutdown? Alternately, are there differences in the times at which these ASs had been affected? Looking at AS-level outages will help us answer these questions. On the right, we see the list of ASs that had been affected, and each is a clickable link. Let's click on the first AS in the list to see the IOTA signals for that AS. We will now see IOTA signals for AS 58224, Iran Telecommunication Company, one of the largest internet service providers in Iran. For this AS, we see that the drop in all three IOTA signals occur at the same time, and we will also note that the drop is very steep in all three data sources. Let's zoom in on when the outage begins and take note of when this outage started for this AS. We will zoom in by focusing on November 16th to November 17th. We can see that for this AS, Iran Telecommunication Company, the outage appears to have begun at 6 p.m. on November 16th. Let's examine a different AS next to see if these timing patterns are different. This time, we will search for a large cellular provider. Let's go to the search bar and look for Irancell, a large cellular provider in Iran. We will see that the outage in Irancell appears to have begun earlier. It began around 2 p.m. for Irancell. However, recall that the large fixed-line internet service provider that we had examined earlier, Iran Telecommunication Company, had its outage beginning at 6 p.m. Thus, by using IOTA's functionality to analyze individual networks, we have learned more about this outage and have uncovered timing differences in when the outage began across networks. These differences may reflect differences in the way the shutdown was enforced. These signals are consistent with a scenario where the government may have ordered cellular providers to shut down a few hours before non-cellular providers, resulting in the outage occurring earlier in cellular networks. Let us now discuss some pitfalls in interpreting IOTA data. The first is that not all internet outages detected by IOTA are caused by government shutdowns. Other events, such as large power outages, can also result in internet outages. Another issue is that there can sometimes be gaps in IOTA's time series curves. Such gaps are not indicative of internet outages. They indicate issues or problems on IOTA's infrastructure which resulted in loss of data. IOTA can also detect false positives and negatives in small countries or regions where the signal is weak. When there are relatively few networks in a region, the magnitude of the IOTA signals will be small, resulting in more fluctuations and noise. Consequently, there are more false positives and negatives. Another pitfall that we are working to address is that IOTA can sometimes miss cellular outages. This is because cellular networks use some very different technologies from fixed-line networks, such as the use of extensive carrier-grade NAT. Of course, we are working continuously on addressing these pitfalls so that the system can automatically take care of them. But in the meantime, it's good to be aware of them so that we can interpret IOTA signals appropriately.